This is the world's largest Nerf gun. This is a normal Nerf gun. And for the past year, I've been making good use of my time by working on this, the world's smallest Nerf gun, where you can actually cock it back and fire a dart. And while this is now the current world's smallest Nerf gun, our goal for today is to break that record not once, not twice, but 3 times, shrinking it by a factor of 10 each time we move down. And if my math's correct, that means by the time we get here, you'll be able to fit 5 of them across the width of a single human hair. But before we can start breaking all these records, we need to talk about the first major problem we encountered just to get here. And it relates to the fundamental way a Nerf gun works. Because when you pull the gray cocking mechanism back, it brings this spring-loaded piston with it all the way back until it hooks in with this catch mechanism. Now we're loaded and ready to fire. So now when you pull the spring-loaded trigger back, it forces the catch mechanism back down, releasing the piston plunger, which quickly springs forward, forcing all the air in the chamber out. And since the lightweight foam dart just happens to be in the way, it goes along for the ride. And if you actually take one apart, you'll find it's made from 87 parts, 13 springs, and 6 hinges. And so the first problem you faced if you're trying to shrink that down to human hair scale is it would be impossible to assemble those tiny mechanical springs and hinges, which left us with the incredible challenge of trying to make our entire tiny functional Nerf gun out of only one single part with no springs. And as it turns out, there's only one place in the world that leads the research in creating really tiny bendable machines from a single part, and it also just happens to be where I got my undergrad degree in mechanical engineering, which meant it was time for me to head back to my alma mater, BYU, to visit some old friends, starting with one of my favorite professors, Dr. Howell.
Hey.
Good to see you, Dr. Howell. I'm trying to remember what grade I got in your class.
I looked it up this morning.
I'm guessing an A-.
Oh, man, that's right. Well, if I disclose that, that's a
violation
of federal privacy.
For what it's worth, he teaches much better than he poker faces.
And who would have known that this bright, energetic student sitting in this class was going to become one of the most famous engineers in the world?
Not me. I'll tell you that much. Not me. And I say that with confidence, because he was also able to locate my student ID. And the only thing more aggressive than those eyebrows was the decision to rock the double puka shell necklace for picture day. Our first stop was to finally meet in person with a group of BYU students I'd been working pretty closely with on this project for about a year. So today was all about a final meetup to see if this was a mission accomplished situation for us. And Jacob, who led the student team, summarized the second major issue we faced here.
The physics of scaling down is huge here. Friction and surface forces are multiplied exponentially.
Besides the difficulty of assembly I mentioned before, this was the second reason we needed it to be made out of one part, to eliminate the exponential friction forces between moving parts at tiny scales. Our plan was to come up with a template design that was full size, and if that worked, we would just keep scaling that exact shape down. But what should that look like? For example, how do you even store energy to fire a dart with no mechanical springs? Well, here was the first prototype, and while it's still more than one part, you could see the clever way the springs were replaced with the few new parts that stored energy by being flexible. In engineering, we call that a compliant mechanism, and I happen to know the world's foremost expert in that field. This is the book on compliant mechanisms.
Oh, I think so, but I may be biased.
And he's as humble as he is biased, because this is hands down the #1 cited book in this field.
A regular mechanism is going to have rigid links, and something like hinges are going to make it move something like this.
And this is a very common type of mechanism called a 4-bar linkage, and Dr. Howe explained how you can make that out of only one part.
We get our motion from something that bends and flexes.
And this is a great demo because if you overlay them on top of each other, you can see the resulting motion is totally identical.
And that is compliant because it's flexible, and that is a compliant mechanism.
And as Dr. Howell went on to explain, the compliant mechanism version offers 6 advantages. Number 1, it's fewer parts. In this case, 8 versus 1. Number 2, lower cost. There's no labor for assembly, and the whole thing can be made in one process, like 3D printing in this case. 3, it's more precise. It always returns back to the exact same spot, and there's no slop between different parts, like the hole in the hinge. 4, lower weight. This is crucial for space applications. 5, no friction between parts. That means no wear between moving parts and no need for lubrication. And finally, number 6, you got built-in springs. Every material has built-in springiness, so the shape we choose can cleverly take advantage of that. He then proceeded to show me some other mind-bending examples of compliant mechanisms, like this single-part light switch, or this single piece of metal bending in ways it feels metal shouldn't be allowed to bend, or this single sheet of plastic cut in such a way where it's really flexible in one direction, but really stiff and unbendable in the other. They've commercialized some compliant mechanisms like this one-piece windshield wiper for surgical cameras, so doctors can use one hand and clean the lens like this, instead of constantly pulling it out and doing this. And they've even done some work for NASA, where you can get a thruster to point in any direction using a single titanium structure that bends and just 2 motor inputs. And so back to our Nerf gun, after many more prototypes, investigating countless different ways to store the energy, we landed at 3 final candidate designs, all of which achieved our primary design objective.
There's no assembly, it's just all printed as one part.
The first design was a zigzag and looked really cool, but the flexures didn't store that much energy per deflection because they're just in bending. The second design was a fishbone, and it was better at storing energy using a combination of compression and bending, but the bending ribs weren't very long, and longer ribs will lead to more power. And so for the third and final design, Jacob accommodated longer ribs by offsetting the backbone, so to speak. And this ended up being the most optimal design. And if we swap out the plastic with a metallic alloy, it could store more energy per the same deflection, which means it can fire a dart even more powerful than an ordinary pneumatic Nerf gun. Plus, it sounds really cool. And now that we've settled on our template design, darn it, that was almost cool. It was time to set our first world record by shrinking this template down 10 times smaller.
So this is 3D printed using an SLA printer.
And what's cool about this relatively new process of 3D microprinting is that you can achieve orders of magnitude finer resolution than your typical PLA printer at home, which is why I was so stoked to finally try and fire it for the first time.
So this is actually a little 3D bullet.
Oh my gosh, yeah, you can like put it right there in the chamber? No way. Okay, ready? When you cock it back, you see the flexures are in fact bending, storing the energy just like at the full scale template. Oh, that's so satisfying. Okay, loading. Yes. Okay, here you go. That was amazing. It fires the dart around 3 feet, which is really interesting because that's also a factor of 10 scale down from how far a normal Nerf dart fires. All right, Bethany, it's only appropriate we have a Nerf blaster accuracy contest. There's a penny out here. Closest to the penny wins. Are you ready? Okay.
Like 6 inches.
3, 2. Oh man, mine went so far! And while mine did shoot further, Bethany was closer to the penny, so she earned the W. New world record, world's smallest Nerf fight. And by the way, we're making all the CAD files we used available on Thingiverse for free, so you can have your own 3D printed Nerf battle at home. I'll leave a link in the video description. There's even some designs there that are Lego compatible, so you can get real clever and design your very own compliant mechanism. Now it's time to shrink down to 100 times smaller than a normal Nerf gun over in the Micromechanisms lab. But before we did that, I asked to make a quick detour for a very specific reason. This is where I lived freshman year. I got something to show you. It was the smell more than anything that really brought back the nostalgia. It smells like a bunch of 19-year-olds with questionable hygiene. This was my room, 3204. Lucky for me, they were between semesters, so I could have full access to the room to get right down to business. I invented a way to break into other dorm rooms in like 1.4 seconds when we were here. And when I left, I hid it in this air vent. So we're gonna see if it's still there. Well, it's not there, which means there's only one option. We gotta make a new one. So to make one, you just start with the roll of duct, wax dental floss, brush off the unused uranium, you should be good. Still remember after all these years. Locked. Now I want to stress, this is for emergency use only. Like if you want to play Mario Kart in Scott Glacier's dorm and he's not home. I still got it. And so with mischief managed, it was back to work. Wow, that is minuscule. And at this size, we had to use a microscope to see what was going on. Can we fire this thing?
Absolutely.
And on top of that, there's no possible way I would have the dexterity to load it up with tweezers, so we used a micro manipulator instead, where each turn of these knobs will move the needle probe fractions of a millimeter in any one of 3 directions.
All right, now continue going down.
Oh my gosh. And it feels a little bit like defusing a bomb because you have to be so incredibly careful since the slightest turn of a knob in the wrong direction. Oh no. Oh no. Can immediately destroy the delicate carbon nanotubes. Which reminds me, I forgot to mention this version of the Nerf gun is actually grown from carbon nanotubes because there just aren't many other ways to make something this small and precise. It's a two-step process Bridget walked me through where you start in a clean room and use photolithography to create a pattern on a silicone wafer very similar to the process of making microchips. Then for step 2, using the wafer as a mask, you get a thin layer of iron in the spots where you want the tubes to grow. Then you put it in a furnace and then blow very specific gases over it at very hot temperatures. The whole process only takes about 8 hours, but when you're done, you're left with incredibly precise, tiny little structures. Don't screw this up, Mark. The smallest firing of a Nerf gun ever. In 3, 2, 1. It's gone! Well done, team! It's kind of like it's there, and then it's not there. There's just something so satisfying about seeing a compliant mechanism design still function just as well, even when it's 100 times smaller than the original. With that out of the way, all that was left was to challenge an ant to a Nerf battle. This is actually like a perfect scale for an ant. And I actually tried to start some beef here by firing a dart his way, but he was seemingly unintimidated. Hey, get back here. Wow! Oh, he took it! Okay, he was definitely unintimidated. He took my gun! Now you guys made one an order of magnitude smaller than this, right?
Yeah, 1/10 that size.
Whoa. But before we get to that, you should know that the water fight equivalent to the world's largest Nerf gun is the world's largest Super Soaker. And sadly, you can no longer buy normal Super Soakers, but we've designed something that's better for 2 reasons. Number 1, you get to put it together yourself so you actually understand and see how it works. And number 2, there's a secret prank built in because after you spray your brother, you do the right thing and give him a free shot in return. But before you pass it over, you discreetly turn this valve. Then you watch him self-own. And then you run. And if you want to experience this toy for yourself, then you're gonna have to get a Crunch Labs Build Box subscription where you get a super fun toy every month, which comes with a video where I teach you all the juicy physics that make the toy work. So if you want to have a ton of fun while learning to think and prank like an engineer, visit crunchlabs.com to learn more. Back to breaking world records, it was once again time to shrink down by a factor of 10, which makes this spec right here 1,000 times smaller than a normal Nerf gun. Whoa. And so in order to truly appreciate the proper scale here, I had to make a sacrifice. Got one. Oh, wow. Look at that. Now, admittedly, these are just the outline without the internal compliant mechanism. In part because even if it were there, it's just too small, so we'd have no way to actually cock it back and pull the trigger. And so for the 4th and final world record, it was time to shrink down one last time by a factor of 10 to land us at 10,000 times smaller than a normal Nerf gun. Now I just had to find it. And is that on here as well?
Yep, just scroll up.
No, 5 of those would fit across one of my incredibly unhealthy looking hairs. And at this point we had to upgrade to their electron microscope to properly appreciate the scale here as Ivy walked me through the resulting images. Wow, that's a cool shot. And that's a human hair there, but to even appreciate how small a human hair is, we found a dead ant outside, and you can see at this scale, it looks like a giant alien monster by comparison. I also found it fascinating to see what the carbon nanotubes actually look like when you zoom in this much. And so without the aid of an electron microscope, that final world record Nerf gun is an imperceptible speck a 1/5 the width of my hair right here. And that's insanely tiny. But in an effort to do a better job at protecting this record for my buddy Mr. Beast, I knew I had to go even smaller. And not just an additional 10 or 20 times smaller. We're talking 300 times smaller. That makes it 3 million times smaller than a normal Nerf gun. It's so small, in fact, that a single drop of liquid like this could contain trillions of them. And I know what you're thinking. Mark, that's crazy. I mean, at that scale, you basically need to fold a DNA helix into the shape of a Nerf gun. Which was precisely our plan. And to pull it off, I need to head down to the Salk Institute in San Diego, California. Now, Salk is a nonprofit biological research institute founded by Jonas Salk. And my favorite thing about him is not necessarily that he discovered the cure for polio, but that after doing so, he decided to forego the $3 billion he would have made by patenting the vaccine and instead made the cure available for for free to everyone. And that attitude of altruistic, scientific curiosity permeates the Institute still today, creating an environment for discoveries like the helical structure of the DNA molecule, which just so happens to be the exact reason we were here.
The technology we work with is DNA origami.
Yeah.
We use DNA slightly differently from how it's used in biology.
This, by the way, is Pallav. He's a genius who runs his own lab here, and his passion about everything and anything biological is contagious.
I mean, don't get me started on bacteriophages. There's this side.
Pallav explained that if you want to build a house, you first need a blueprint that has all the specific instructions for how to build the house. And the equivalent of a house blueprint in nature is called DNA. Every single cell in your body has DNA that looks like this, with a complete set of instructions on how to build you. And that's DNA's only job in nature. But some of Pallav's predecessors asked an interesting question.
What if you use the DNA itself
Yeah.
as the building material?
So instead of using DNA just as the blueprint to give information to build something else, what if you effectively use that blueprint as a sheet of origami, telling you where to cut and fold so the blueprint itself becomes a tiny little structure? And here's how they actually do that.
So if you think of DNA, right,
Yeah.
it's two strands,
Yeah.
and they're usually complementary. So if you have an A here, you have a T here. If you have a C here, you have a G here.
Right.
And then when they come together, they kind of zip up. A binds with T, and C binds with G, and so forth, right?
Got it.
So if you have two complementary strands, they will zip up and form this familiar double helix
Yes.
structure. But what if they weren't completely complementary?
Okay.
What if like this part here was complementary to this part here, but then this part here was not complementary to this? But then you have these two flimsy parts that haven't paired up yet.
Right.
So now if you introduce a third part, for instance, that binds to these unbound parts,
Yeah.
you can create junctions, right? And those junctions, you could then branch them out and build them further into larger structures.
So using that principle, they start with a naturally occurring single-stranded DNA they call the scaffold strand, and on a computer, they design out the shape they want. Now as it stands here, there's nothing attached to the other side, so it would just lose its shape. But if you add in a bunch of what they call staple strands of DNA that are specifically designed to match the corresponding sections on the scaffold strand, they effectively lock it into the desired shape. So in theory, if you just put a random scaffold strand and then all the corresponding custom-made staple strands in a solution together at the right temperature, and then let it sit for a while, it would automatically self-assemble into an infinitesimally small Nerf gun made strictly from DNA. No way. But since you can't set a world record with just a theory, it was time to make some Nerf guns. So with a little help from Lauren and Amanda on Pallav's team, we got right to work. Step one was to take a solution containing trillions of scaffolding strands of DNA and then mix in another solution containing quadrillions of the staple strands of DNA. Then we placed that magical mix into 8 individual tubes and then placed them in a special oven that would maintain the ideal temperature for the self-assembly process to occur, and we set a timer. Okay, so just come back in an hour and 20 minutes?
Yeah.
So easy. And I feel like I should pretend the whole process was harder than that.
Ready to eat. Ready to eat, yeah.
But when the timer was up, that was basically it. So after a quick final process of using an electric field to separate the successfully merged guns from all the strands that didn't successfully merge, you're left with a few drops of water containing 1.2 trillion of the world's smallest Nerf guns. For the final step, we just needed to prove to ourselves that they were actually in there. And that's where Jocelyn comes in. We need help, Jocelyn. I'm told you are the person to make these seeable.
I can help with that, although there's no label on it.
And what's wild here is it's beyond the realm of physics to build a typical microscope powerful enough to see these, because our Nerf guns are 100 nanometers in length, which is 5 times smaller than the actual wavelength of visible light. So Jocelyn's using an atomic force microscope instead, where there's a super tiny probe that just drags back and forth on a surface, and when it encounters anything as small as a single atom, it raises the probe up, and that deflection is measured using a laser. So if you drag that tiny probe back and forth enough, you sort of feel your way to revealing what can't be seen. So after a little while, Jocelyn returned, allowing me to now present to you a small sampling of the world's officially smallest Nerf guns, made entirely just of DNA. Are you kidding me? Pretty freaking good. And what blows my mind is that each of these is made from just a few thousand atoms. To comprehend just how small that is, if you laid them end to end, it would take 2,000 to fit across a single human hair. Your move, Mr. Beast. So as I closed out my visit, Pallav let me know about how this project had sparked some ideas for his team.
If we can make specific nerf blasters, or whatever you want to call them, DNA injection devices, and we can target particular kinds of cells, then we can make much more targeted treatments for a range of diseases. But in all of these therapies, you need to deliver the correct DNA. So how do you get those into the cells?
Nerf blaster.
Nerf blaster.
Okay, so this is really just the beginning. In a couple of years, we're going to come back to the sequel to this video. Does that make me a co-author on this paper?
Well, you definitely co-author on the paper.
Okay.
I don't know on the Nobel Prize.
And as I closed out the trip, I couldn't help but feel a little extra glimmer of hope for us humans. Because by giving them an admittedly ridiculous challenge, I got a tiny glimpse of the cutting-edge research happening at both BYU and the Salk Institute. And while a Nerf gun by itself won't do much to help humanity, it was a small reminder that millions upon millions of engineers and scientists in labs all around the world are dreaming up the big ideas, working hard right now to improve the lives of future generations by solving some of the toughest problems of our time. It's a sentiment possibly summed up best by Jonas Salk himself. Hope lies in dreams, in imagination, and in the courage of those who dare to make dreams into reality. What I love most about people like Jonas Salk and Pallav is the creative confidence they exude as they approach the tough problems. It's an attitude that can be learned, and it's why the goal of every Crunch Labs build box is to help you think like an engineer. But the learning doesn't feel like learning, because every month you're having tons of fun with a really cool toy that you put together yourself, where you learn all the physics behind what's going on while building your creative confidence along the way.
It worked!
And since the holidays are coming up, there's nothing more fun to put on your list, nor is there a better gift to give than an investment in the future of the favorite young person in your life as you watch their confidence and resilience grow. Yes! And possibly the coolest part of all is each month we randomly select one box to slip in a platinum ticket. And if it happens to be yours, and you're coming out right here to Crunch Labs to design with me and my team for a day. So if you want to unlock the superpower of learning how to create and build whatever you can dream up, even if it's really, really small, just head to crunchlabs.com or use the link in the video description to learn more. Thanks for watching.